Hi students, welcome to Physics for Everyone classes. This is your Satish. In this section, we can see one of the important model or the question from the fluid mechanics. It is related to accelerated fluids. There you can see the problem. Here we have got a container which is filled with a liquid. Here the liquid is the water. And there is a one sphere whose mass is given as 2 kg and which is connected by a string to the bottom of the container. There you can see the density of this sphere, which is 500 kilogram per meter cube, and the density of water is 1000 kg per meter cube. When you see these two values, you come to know the density of the sphere, which is less than the density of water by how many times? 1 by 2 times. So if you cut this string here, this will go up, and how much volume which will be outside, there you can see how much the volume which will be outside and how much the volume which will be inside. It depends on the densities. According to law of flotation, we can write weight of the object is equal to the buoyancy force acting on that sphere. With that you will get V volume. You can see the volume inside divided by the entire volume. The fraction of volume inside the liquid is given as volume inside and total volume. What do you get? The relation density of the sphere divided by density of the liquid or water. And the density of sphere is given as 500 and water is 1000. You will get 1 by 2. The fraction of volume which will be inside the liquid, you will get how much? 1 by 2. And what we are going to find here in this question, the one in the equilibrium condition, when the thread is connected to the bottom of the container, how much is the tension there in the string? The first question. Second, if the string cuts, if you cut the string, what will happen? Because of the decrease in density of the sphere, lesser density, it will move upward, and there the volume, the fractional volume which is there inside the liquid comes as 1 by 2, means half of the sphere outside and the remaining half will be in the inside the liquid with this relation. And then we need to find the acceleration of the sphere as it is moving up with respect to the tank. That is the question. FBD, free body diagram for sphere. Here we have the sphere of mass and there the one string is connected to the sphere here, and we can say this is the point of contact. Now, what are the forces which are acting on this object? There you can see the gravitational force will be acting in downward direction, mg. Because the string is connected at this point with the bottom surface, the tension always acts away from the point of contact. If you consider this is the body, you need to take the tension away from this body. At this point of contact, it is acting away. Tension never pushes the object. Tension always pulls the object. As the whole object is there inside the liquid, it experiences the maximum buoyancy force. How much it is? FB, buoyancy force. You can see the one is the buoyancy force in upward direction, and second is tension, and the third is weight of the object. And the whole system is moving upward with an acceleration E is equal to 2 meter per second square. Now we can write the force equation, Newton's second law, for to find the tension here. Before that, what we can write here, the buoyancy force expression. So FB is equal to, as we know, we can express it as volume inside. How much volume of the object is inside the liquid, VIN, density of the liquid into acceleration due to gravity, G, when the object is in the inertial frame. But here the sphere is in a non-inertial frame because the whole system is moving upward. We need to take effective gravity. How much it comes? G plus A. The effective gravity which is acting on this object. How much? We need to take G plus A in the buoyancy force equation. So take care while we are dealing the accelerated fluids. If any object is there inside it will experience the buoyancy force with the gravity where it comes as the effective value which is equal to how much? G plus A. So after getting this one, directly we can write the net force acting on this mass is equal to mass into acceleration. How much you will get? CFB, buoyancy force, minus 2 downward forces are there. We can write it as T plus mg, that is equal to m into E. Upward force is FB, downward forces are T and mg. So minus T plus mg is equal to mass of the sphere into acceleration of the system. Now keeping the values here, we can find the tension. So what we can write here, FB is equal to, because the whole sphere is inside the liquid, total volume we need to take, volume inside, density of the liquid means water into effective gravity G plus A minus T minus mg, which is equal to m into E. We need this T value, so take this T to that side. There you will get tension T is equal to, so V dW G plus A minus mg is there, and this ma will come this side, you will get minus ma. If I take minus m common, you will get G plus A. Now put all the values here. So in the question it is not given the directly the volume of the sphere. Instead we can write volume is equal to mass by density. How much mass? 2 kg. Density is 400. All are in SI system. And density of water is 1000. And G plus A. G is given as 10 and A is 2. And 10 plus 2 is 12. You will get minus mass is again, you need to take 2 into G plus A, 10 plus 2 is, you will get 12 here. Here 500,000 is there, and these 2 will be cancelled how many times? 2 times. 2 into 2, 4, 12 4s are 48 you will get, minus 12 2s are 24. So 48 minus 24, how much you will get? You will get 24. So the tension which is produced inside this string as the system is moving upward with an acceleration 2 meters per second square is how much? 24 newtons. Now we are cutting this string. What we are going? Now we are cutting this string, and because of the buoyancy force, more buoyancy force, it is moving in the upward direction. Here the one buoyancy force is there, and the other comes as only the weight of the object. Here the tension comes as 0 because as it is a string, when you cut, the moment the tension comes as 0, there will be a net unbalanced force. We can see with that the object is moving in the upward direction with a new acceleration with respect to the ground. There you can see. So with respect to ground, I'm writing the force equation to find the acceleration of the sphere with respect to ground first. Later we can find with respect to the tank. Now what are the forces which are acting now? After the tension comes as 0, there you can see this is a sphere of mass m, weight is in downward direction, buoyancy force is upward, there is no change in the values of these two, and with these two the object is moving with an acceleration, suppose a dash. It is moving with a different acceleration, it is moving upward. Okay, so now this person, I'm writing this equation in the inertial frame. So this person is observing this acceleration a dash. So what we can write? So buoyancy force minus mg, which is equal to m into a dash, where a dash is the acceleration of the sphere in the inertial frame. Now the buoyancy force comes as the same value which we got earlier. How much we got? So volume, density of water into gravity, g plus the effective gravity. Be careful. We need to take all the time in the buoyancy force equation, in the place of g, must write g plus a in the accelerated frames, minus mg, which is equal to m into a dash. Now volume is how much you got? Volume is mass by density, which means 2 by 500 into 1000 into, we have done earlier, g plus a, 10 plus 2, which is 12, minus m2 into gravity is 10, which is equal to 2 into a dash. This is 1000, cut these two. 2 times will be get cancelled. 12 fours are 48. So 48 minus 20 divided by 2, which is equal to a dash. So you will get a dash is equal to how much? 48 minus 20, you will get 28 divided by 2, which is equal to 14 meter per second square. So you got the acceleration of the sphere in the inertial frame because we wrote the equation, the Newton's second law, according to the inertial frame. So this person says that the sphere is moving upward with 14 meter per second square. But in the question it is asked, what is the acceleration of it with respect to the tank? That means with respect to this person, the acceleration is how much? So as both are moving in same direction, we need to take the difference of, or you can write acceleration of the sphere with respect to the tank is equal to acceleration of the sphere minus acceleration of the tank. This is a relative acceleration concept. AST, acceleration of sphere with respect to the tank is equal to acceleration of the sphere minus acceleration of tank, which is equal to acceleration of sphere with respect to ground we got in the upward direction, take positive. So 14 minus acceleration of tank is also in the upward direction with respect to ground. You take this is also plus 2. That is equal to 14 minus 2, you will get 12 meter per second square. You got the positive answer, which means acceleration of the sphere with respect to tank is also in the upward direction. So you got the final result. So when we got the tension, when a string is connected to the bottom, if the string cuts there, the sphere is moving in the upward direction with an acceleration. With respect to inertial frame, we got the answer 14, and with respect to the container, we got the answer 12 meter per second square. So in the entire concept, the main thing is that while we are writing the buoyancy force equation, if it is related to accelerated frames, there we need to take, in place of g, take the effective gravity value, which is as it is moving in the upward direction. There you can take g plus a. So that is the key thing there in this question.